Hello everyone, I'm Rohit and in this video you will get an idea about what Green GPS is and how it is implemented. Now Green GPS is very much similar to Google Maps. Now Google Maps basically tells us about the shortest or the fastest route between any two arbitrary points. Similar to Google Maps, Green GPS tells us about the green path between any two arbitrary points. Now what does green path mean? Green path basically means that it will tell us about a route which will consume the minimum amount of fuel. So summing this up, we can say that Green GPS basically tells us about the most fuel efficient path between any two arbitrary points. Now, what is the reason or why implementation of Green GPS is extremely important? Now, studies have shown that if Green GPS is implemented, it can provide a potential savings of around 10%, which when translated in economic terms can give us a cashback of 20 for each gallon of fuel consumed. The more prevalent Green GPS gets, the more positive effect will be visible, and it will reduce the amount of CO2 in the atmosphere and the carbon footprints for vehicles. Okay, now talking about the implementation part, the implementation of Green GPS is basically done with a combination of several open source software which helps us in finding out the fuel efficient route. Now, when Green GPS is implemented, it is extremely important to collect the data and analyze the data. Now, one of the method of collecting the data is by using an Android application running on user's smartphone. The application so developed is basically designed to collect the user's fuel consumption, its speed information, which will be combined with the user's current location using the phone's GPS, and the data so collected is then stored in the backend server. Whereas in some other method of data collection is by using a proof of concept study where 16 or more than 16 users different cars data is examined for a period of 3 months. Now model structure derivation. Structure can be derived by using the OBD2. Now what is an OBD2? OBD2 is basically an interface which was developed by US after 1996 and is almost present in all the cars. Basically using the OBD2, Green GPS is able to provide the fuel efficient route information. So structure can be derived by using the OBD2 data shared by an individual to compute regression models which help in fuel consumption on specific streets making use of the car details. Whereas other methods can be by the physical analysis to derive the structure of the fuel prediction model. The analysis is straightforward. The analysis comprises of plotting the distribution of miles per gallon for all the data collected. The graph here shows the real MPG distribution of all the 16 users. Now, traffic signal location detection is extremely important when a route between any two arbitrary points is being provided to the user. Now, an SVM based classifier using the curve package in the statistical tool R is built to detect the location. Using the dataset collected in the part of Los Angeles, for example, the classifier is trained to detect or predict the traffic signs. Now, evaluation of model. For estimating the coefficient of models with known structure regression analysis is a standard technique. Now, a single regression model is bad fit for our data. So, it is not trivial to generalize in a sparse data set because data obtained from pool analysis is very different from individual data. Now, this table basically summarizes the cumulative percentage errors for the individual car and the generalized case when all the data is used to obtain the model. It is basically a comparison between different methods being used to implement Green GPS. Now, now talking about the model clustering, each car has a different behavior. Although the data collected deals with car weight, car frontal area, and many other attributes, they are not enough to put forward the main differences. The solution to this problem is OLEP, which stands for an online analytical processing, which can be used for multidimensional analysis and will give much more details so that you will be able to differentiate between different cars. So with this, the implementation of Green GPS ends.
Hello, I'm Akshay Mahajan and I'll be talking about participatory sensing. As we know that today mobile phones are more powerful than ever. They have sensors like camera, microphones, GPS. So these can be used to explore things which are important to us in the environment, like from health to culture. So participatory sensing is an approach to data collection and interpretation in which individuals can use their mobile phones and web services to systematically explore things, interesting aspects of their worlds, ranging from health to culture. Participatory sensing can be used to retrieve information about the environment, weather, urban mobility, congestion, as well as any other sensory information that collectively forms knowledge. We can examine the individual traces through various scientific models, which can give us a profound understanding of the world around us. This is participatory sensing. Participatory sensing can be implemented in various domains. For example, discover the community's impact on air pollution, or in the domain of green computing to find the shortest path to the destination with the least amount of fuel burned. This can be done by locating and identifying the pollution sources. Photos can be clicked through mobile phones, geotagged, and then uploaded to web servers. These geotagged photos can then be catalogued, analyzed by software for a given participatory sensing project. Another application of participatory sensing is in the field of transportation. One project is how long to wait. In this project, the person waiting for the bus can know the expected time of bus to arrive or how long to wait for the bus. While boarding the bus, people will use their mobile phones which will send the bus route from the cell towers to the web server. The web server will determine the expected time to reach the waiting person using the participatory sense data on the web server. Accuracy on the results can be improved with the increase in number of users of the app and also by the concatenation of the bus routes after the people get off the bus. Now we see the previous related work. Several early applications include Senwits, a participatory sensing network to search and rescue hikers; Cartel, a vehicular sensor network for traffic monitoring. Green GPS introduces a novel example of this genre that enables individuals to compute fuel efficient routes customized for their vehicles. Now we see how participatory sensing helped us to find the fuel efficient routes using Green GPS. So the theme is a navigation service that allows drivers to find the most fuel efficient routes customized for their vehicles between arbitrary endpoints. So first the user will install a Green GPS app which will collect the user data, send it to a data storage which will also contain the routes and trip data, the model car and map database. This will be connected to OSM database and ODP manager. Now the geocoder algorithms will help to model the traffic and also find the fuel efficient routes. Green GPS accomplishes this by exploiting the vehicular sensor measurements available through the onboard diagnostic, which is ODB2 interface of the car. Individuals share their OBD2 sensor and location data. An Android application automatically uploads the data to the aggregation server. This aggregation server uses the data to calibrate models that relate street and vehicular parameters to fuel efficiency and offers a green GPS navigation interface for fuel efficient routes.
Related work. Previous work in participatory sensing. Several early applications include Senwits, a participatory sensing network to search and rescue hikers; Cartel, a vehicular sensor network for traffic monitoring; an application called CabSense, which is a cab sensor network to find best corners to catch taxis depending on the current location and time. So basically, you can actually see how you can catch a cab from the nearest point from your location. BikeNet, a biker sensor network for monitoring popular cyclist routes. An application called ImageScape, it's a cell phone camera network for sharing diet-related images. More recent applications would include Microblog, a content sharing platform; Pyre, a report system enabling individuals to measure and compare their impact on environment as well as their exposure to environmental emissions. Application called Escort. It's an electronic escort system that enables localizing people. Movie, a service for covering social events and a service to determine buses' arrival time. In our application Green GPS, it is a novel example of this genre that enables individuals to compute fuel efficient routes customized for their vehicles. There's been some work on fuel saving in transportation too. So, UB Green is a mobile tool that tracks an individual's personal transportation and provides feedback regarding their CO2 emissions. Kenatel proposes to exploit information on surrounding vehicles and road conditions in designing eco driving systems to achieve higher fuel savings. Social Drive is a crowdsourcing service that provides feedback to drivers regarding their driving behavior. An application called Karma provides high level abstractions for sensing and tuning automobile engine parameters to achieve fuel efficiency. The turning can be done at the granularity of individual trips. Signal Guru is a participatory sensing based system, is a traffic signal schedule advisory application that assists drivers to adjust speed and avoid coming to a complete stop. An application called QI proposes to use RFID based e stop signs at unsignalized intersections to alter drivers' behavior properly, early, and achieve potential emission reductions and fuel economy improvement. So basically, it uses RFID based e stops, and so whenever there's an intersection or whenever there's a traffic signal coming, it it notifies the driver prior, and so that the driver can behave properly and can and doesn't have to stop or accelerate all of a sudden. There exists a large category of work such as VTrack that collect real-time traffic information and provide estimations on road travel times in order to aid users route around traffic congestion. Q develops a network sensors based real time traffic queue monitoring system for developing countries, which can lead to improved automatic traffic signals scheduling in order to reduce fuel inefficiency. Some other works like Phone Park approaches reduction of vehicles gas consumption by detection of available on-street parking spaces, which enables users to minimize their travel distance searching for parking. Phone Park uses the GPS and accelerometer sensors of travelers' mobile phones. So it would give information on the free parking spaces so that the user doesn't have to go around the whole area searching for a parking spot. Co-ride, among others, proposes the use of carpooling to share rides, and it helps in reducing gas consumption.